Hello friends, today we are going to learn about 8254 programmable interval timer. Now this programmable interval timer is used for generating the fixed amount of time delays or for counting the external events that are happening in outside the world. Now in case of 8085 microprocessor, this 8085 microprocessor is not having dedicated timer or counter inbuilt in itself. So in case of the timing or counting related applications, we need to interface this external timer 8253 or 8254 with your 8085 microprocessor. One more advantage of interfacing this 8254 or 8253 programmable interval timer with 8085 microprocessor is that you are assigning a dedicated utility to your 8085 microprocessor for generating time delays as well as for counting the events, rather than tying down your 8085 microprocessor in doing one-on-one operation only, that is to tracking the count or for to tracking the contents of one specific register, as we can generate time delays with the help of single register or using register pair or with the help of loop within the loop technique with the help of DCR and DCX instruction. But in that case, unnecessary wastage of timing of microprocessor takes place. Microprocessor gets tied in doing one task only. So it is better to have a dedicated timer which can be used for generating time delays as well as which can be used for counting the events. So today we are going to learn about this 8254 programmable interval timer. We are studying this 8254 which is an advanced version of 8253 programmable interval timer. Basically both are same, just 8254 is having one advanced readback command. That command is not available with 8253. As you can see, this 8254 is a 24-pin IC. First 8 pins, pin number 1 to 8, are for data lines D7 to D0, which gets connected with D0 to D7 of your 8085 microprocessor. Next pin number 9, 10 and 11 are for counter 0 in your 8254 programmable interval timer. Programmable interval timer 8254 consists of 3 counters. Each is having 3 pins. Out of that, 9, 10 and 11 pin represents the pins of or signals of this counter 0. Pin number 12 is ground reference. Pin number 13, 14 and 15 are signals for counter 1. Pin number 16, 17 and 18 are signals for counter 2. Now what exactly the signals are, clock 0, out 0 and gate 0, will learn. I will tell you in next lecture. Before that, you just have to keep in mind that this pin number 9, 10 and 11 are for counter 0, then 14, 15, 16 for counter 1, and next 17, 8, 6, pin number 13, 14 and 15 are for counter 1, pin number 16, 17 and 18 for counter 2. Then this pin number A0, A1 along with this chip select signal provides selection among counters as well as control word register. Means this pin will decide with which counter we are going to work, with which counter we are going to operate, that will be decided by this pins. CS bar is for selecting that particular chip, that is 8254. How exactly selection takes place, I will check out with the help of different combination. Then pin number 22 and 23 are basically read and write control signals for reading and writing the information from or to 8254. This gets connected with IO R bar and IO W bar signals of 8085 microprocessor. If you remember in class, we already have studied generation of control signal, which is again an important part, that 8085 is not having a dedicated control signal for performing reading and writing operation with IO or memory. So that control signals are generated by quad 2 input NAND gate, reading and writing signal for IO devices as well as for memory. So those two signals are gets connected with IO R bar and IO W bar signals of your 8085 microprocessor, and pin number 24 is supply pin, that is plus 5 volt supply. So this is all about 24 pins of 8254. In next lecture, we'll study the block diagram of 8254.